the idea basically of demand is that we know a person will sell something, they will be on the, if you will, selling side of things if what they're getting is worth more to them than that they're giving up. But if you're a buyer is somebody who's getting something and giving up money. So that's principally what makes you a buyer, is just when you're doing this calculation, estimation, however you want to think about it, as to whether to undertake a change, to do something new, to buy something that you don't already have. Is the utility you're going to get from that bigger than the money that you'd have to give up to get it? In other words, is the value to you in your own mind, the marginal utility you're going to get from the good, bigger than the price, bigger than the other things you could have spent the money on that you're spending instead on this good? So what we did is we had an example of 6 people. We looked at their utility expressed in terms of money, and you had each of these individuals. Alberto, the item that they were thinking about buying was worth $10. For Bianca, it was worth $9. For Carlos, it was worth $8. For Diana, it was worth $7. For Eric, it was worth $5. For Frida, it was worth $4. And to summarize them and to put them all together, instead of thinking about them as individuals, we could ask the kind of question: how many of the items that we're talking about would give somebody, and we don't care which person it is, but would give one of those people at least an amount of utility equal to or bigger than each of these amounts of money? So it's kind of like if you offered this person, oh, which would you rather have, $11 or this good? How many items would there be that someone would say, well, I'd rather have the good? Well, in our example here, if these are the only 6 people involved, the only 6 people who know about the good or whatever, if the price was $11, nobody would say, yes, to me, the value of the good is at least as big as $11, because the highest value that anybody places on the good is $10. That's Alberto here, right? So 0 people would say, yes, to me, the number of items that I would think would give me at least as much utility, adding together for all the people that there are who know about the good, the number of items that give that much utility, $11 with utility, is 0. However, the number of items that would give at least $10 worth of utility to somebody is 1, and that's Alberto. The number of items that would give at least $9 worth of utility to somebody is 2 items. Well, what is that? Well, the item that Bianca has is worth $9 to her, that she's thinking about buying is worth $9 to her. And that item would be worth $10 to Alberto. So there's 2 items that potentially you could sell to these people that they'd be willing to pay at least $9 for. At $8, there are 3 people who would say that. At $7, there are 4 people who would say that. Therefore, 4 items that would be worth that much to somebody. Alberto thinks one of the items is worth $10 to him. Bianca thinks one item is worth $9 to her. Carlos thinks one of the items is worth $8 to him. Diana thinks one of the items would be worth $7 to her. So altogether, that adds up to 4 items that would be at least worth $7 to somebody. If instead you asked about $6, well, then it's still only 4, because there's no more people here who would pay more than, who think it's worth at least that much for them. Eric only thinks it's worth $5 to him, so he wouldn't pay 6, right? But he would pay 5 if we lowered the price to 5. So then we'd have to throw Eric in with the group of the other people, because all of these people here, Alberto, Bianca, Carlos, Diana, and Eric, would all think that one of the items would be to them worth at least $5. So we get 5 items there that are worth at least $5 to somebody. Excuse me. Then, if we lower the price to $4, we'd also pick up Frida. Frida thinks the item's worth $4, so she would be added to the other 5, and that would bring our total to 6. So the number of people who would think that the item was worth at least $4 would be 6. So again, we're measuring in a kind of aggregate, adding together people sort of a way. We're measuring their marginal utility, or at least the answer we get for this little table here is based on the utility of the potential buyers, the people who are measuring their utility against the money that they'd have to give up to obtain the good. So we have some definitions. We call the number of items that somebody thinks would give them at least that much utility. We don't care who it is who thinks that, but the number of items that people would be willing to buy, that's called the quantity demanded. It's the amount of a good that buyers are able and willing to buy at a particular price. Now, we represented it here, the prices and the quantity demanded numbers, we represent that here as a table. If you take the whole table all together and how all these price numbers coincide with the different quantity demanded numbers, and you kind of think of them as a whole, set. That whole set of prices and quantities is called demand. It's all the quantity demanded numbers that go with all the possible prices. Ceteris paribus, we throw the word ceteris, or the term ceteris paribus in there because we want to make sure that the only two things that you are sort of thinking as changing when you look at this table are the two things that are explicitly changing on the table. One of them is the price. The price is explicitly changing. It's moving around, right? And also the quantity demanded, which is also explicitly moving around. So that's demand. Now, there again, demand is a table. It does not have to take that form, however. You could also express or think about demand and represent the information there as, instead of a table of numbers, you could think of it as a graph. The graph indeed would look something sort of like this. Now, this is not a graph of those exact numbers that we just had on that table. This is a graph, though, in general, the form that we would expect to have a demand curve take would be something like this. It would be a downward sloping curve. It doesn't have to be a straight line. This example is, but it does not have to be. We call it a demand curve, and also we include there that it might have some bends or kinks in it. As a matter of fact, if you were to graph these particular numbers, because of the fact that you have here, you're lowering the price by $1, but the quantity isn't changing, quantity isn't going up, then you would expect it to not look exactly like a straight line. It'd be kind of a bend or a kink in it. But the principle is, if you charge a really high price, if you're asking the buyers about a really high price, there would be very few items for which they would say, yes, I value the good more than that amount. So therefore, there might even be no people who would say, yes, I would value the good at least that amount of $10, in which case at $10 on this diagram, the quantity demand is 0. But as you lower the price, there are more and more people who say, yes, now you've finally gotten to a price that's below my marginal utility. So I would be one of the people making up this quantity demanded. So I would want an item there. I would want one of these items if the price goes low enough. At the extreme, if you make the price all the way down to 0, then there is even then probably a limit to the quantity demanded of the good, because even if you gave something away, there might not be, there might be some people who don't even know about it. There might be some people who don't walk into your store or whatever, even if you're giving out free samples, and therefore they wouldn't get it. So if that's true, there is probably a limit, an upper limit, even if you're giving something away, to how many people would take it. But the principle is not these two extremes. The principle is this. As you lower the price, the quantity demanded will get bigger. And that's what's represented here by demand. Now, one of the things that often gets confused by people, and I want to say, sometimes we're going to use the demand curve, sometimes we'll use the demand as a table. We'll probably more often use demand as a graph like this, just because it's sort of easy to summarize the general idea of it. You don't have to, for most people, there's kind of a level of your brain where if you see a bunch of numbers and you try to process them, it kind of, it takes some of your brain power to do that, takes some brain energy to do that. Whereas for most people, if they look at this diagram, once they kind of get the gist of what it's saying, it's almost like an instant shorthand. Most people are, at least to some extent, visual to this extent. They may not be for everything, but to the point that they can kind of get the idea of a demand curve sloping down. It slopes down. It's a graph that slopes down. It begins with a D and ends with a D. So kind of think it slopes down because it begins and ends with a D. The idea is that, oh, look, a high price doesn't have very much quantity demanded, and if you want to have a bigger quantity demanded, you have to lower the price. Lower price, which is on the vertical axis, means a bigger quantity demanded, which is on the horizontal axis. If we are to raise the price, let's suppose we raise the price from 0, right? We raise the price from 0 where there's 100 people who want this good, and we raise the price, let's say, to $5, which is right about there. If I asked you, what happens to demand when you raise the price from 0 to $5? What happens to demand? Be very careful how you say this. What would you say? Yeah. Okay, so be careful because we have these two definitions that you have to not get mixed up. Quantity demanded and demand, okay? Whenever you're looking at something like this graph, demand is all of those numbers, all the numbers of price and all the numbers of quantity, like all together. That's what demand is, right? So it's telling you that when the price changes, it's already got all the prices in it. Like if I said, this demand curve, this line, how many prices are in this demand curve? All of them, right? All the prices between 0 and 10. As a matter of fact, all of them, probably, if you zoom in on this enough, you could get like all of them down to the penny between $0 and $10. So since all the prices are in there already, demand already includes all the prices. It's just telling you which quantity demanded number goes with each of the prices. So if you shoot it a price of 0, it tells you, oh, the quantity demanded is 100. If you shoot it a price of 5, it's probably going to tell you, oh, the quantity demanded is 50. But demand is what's telling you that. Demand itself isn't changing when you change the price. It's telling you how the quantity demanded changes when you change the price. You might start thinking that demand and quantity demanded are the same thing. You might start talking that way, but that would be incorrect. You will be led astray if you fail to get the distinction between these two things. The change in the amount that people want to buy when the price changes, that's a change in quantity demanded. Demand is the thing that tells you how the change in quantity demanded is going to be. But demand itself is not changing. It's just sitting there and you're looking at a different place on it. You're just looking at a different point on the demand. If you will, think of demand as like a map on your phone. If you go from one place to another, and I asked you, oh, what happened to the map of Phoenix on your phone when you went from, let's say, Phoenix College regular campus to Phoenix College downtown campus? What happened to the map on your phone? Well, nothing happened to the map on your phone. It's just the little dot that represented you moved. So think of demand as like a map. What happens to the map when you move from one place to another? Well, again, where you are on the map is going to change, but the map itself doesn't change. It's still true that, like, for example, Thomas Avenue is north of Fillmore. That's still true. Just like it's still true that $10 is up here and $0 is down here, and the higher quantity demanded goes with a lower price. All that's still true when the price changes. So don't get that mixed up. But, I'm going to ask you that several times because it's so easy to get mixed up. And if you do, it's going to really be to your harm to get those mixed up. In addition, though, to demand, we also had supply, right? So the same thing, we had the same kind of situation. We had different people, except now they're selling something. We're representing their opportunity cost in terms of money. So you have Alberto, who thinks this, he'd sell this thing for $20. Bianca, she'd be willing. She thinks that her opportunity cost is 19, which means if you paid her 19 that would overcome her opportunity cost, so she'd be willing to give you the thing, like probably her time, in exchange for $19. Carlos is willing to swap it for $17 because each of these people is asking the question of themselves, is the price that someone is offering me bigger than my marginal opportunity cost? Is this a dollar amount that's bigger than, or at least as big as, my marginal opportunity cost? So if their opportunity cost, for example, with Carlos is 18, and you offered him 18, well, he might do it. He might sell you his time. If with Diana, the opportunity cost of her time is 17, she might do it. If you offered her 17. She'd also do it if you offered her 18, right? If you offered Carlos 17, he wouldn't do it. Right? Because he thinks his time is worth 18. If you offered everybody 15, well, then Diana won't do it anymore, but Eric would, because that's how much he thinks his time is worth. And Frida thinks her time is worth 14. So their willingness to sell this thing, and I'm just giving an example of time, it doesn't have to be time, but their opportunity cost of what they would be giving up if they lost this thing, as long as the money that you're offering them is more than that, they'd be willing to be a seller. So we can take that list of people here, and now, again, aggregating, getting rid of the individuality of the people, you could ask, okay, how many people would be willing to part with this thing if we paid them $20? Well, that would be all of them, right? Because Frida would, if we gave her $20, well, she only thinks it's worth 14. That's what she's giving up. If she's giving up $14 or something that she thinks is worth $14 if she gives it to you. So if you paid her $20 for it, she would think that would be okay. Eric thinks it's only worth $15, so if you give him $20 for it, he'd go for it. Diana thinks it's worth $17, so if you paid her $20 for it, she thinks it would be worth it. Carlos would as well, Bianca would as well, and Alberto would as well. All of them think it's worth $20 or less. But if you lower the price, and you ask them really, okay, how many of you think the opportunity cost of this item to you, of how hard it would be for you to part with or whatever, is $19 or less, well, then we only got 5. Why is that? Because we don't have Alberto on board with that, right? Because he thinks it's worth $20, and we're asking him if it's worth $19 or less, and he says no. Bianca will say yes. Carlos will still say yes. Diana will still say yes. Frida will still say yes, and so will Eric. That adds up to 5, but that's only 5. If we lower the price for 18 to 18, well, then we still have Carlos and Diana and Eric and Frida, but we lose Bianca and Alberto because they don't think it's worth less than 18 or 18 or less. At $17, we only get 3 of them who say, yes, it's worth to me. How much I'm giving up is $17 or less. Because Diana says, basically, I'd be giving up $17 if I parted with this thing, or something that's worth $17 to me. Eric says I'd be giving up something worth $15 to me. Frida says I am giving up something that's worth $14 to me. I'd be willing to do that if you paid me more than that. So there's 3 people for whom they would be willing to part with it if we gave them $17. 16, there's only 2 people, Frida and Eric. 15 also, there's only 2 people, right? So we've lost Diana, but we still have Frida and Eric. Both would be willing to sell this thing if we paid them 15 for it. But if we go down to 14, the only one who's willing to sell it for 14 would be Frida. And if we lower the price to 13, nobody would be willing to sell it. So the number of items that would really, that the potential seller would be willing to sell for, if the price was 13, is 0. Again, we're counting up the number of items that have that cost or less. Now, when you take these numbers, each of the amounts that somebody would be willing to part with at that price, that's called the quantity supplied. The amount of the good that sellers are able and willing to sell at a particular price. So you say, okay, at 15, it's 2. That 2 is the quantity supplied. But all these numbers taken together would be supply. All the quantity supplied numbers that go with all possible prices, this whole table, this whole thing here is supply. So if we say, what happens when the price goes from 14 to 16, you can say, oh, the quantity supplied will go from 1 to 2. But don't say supply goes from 1 to 2, because supply is not a number. It's all the numbers. The thing that's a number is quantity supplied. So, again, make that distinction. Get that distinction straight, and it'll save you from some trouble. The graph showing all of the things that the sellers would do. It would look something like this if we graphed those numbers that we had in the previous example. It would look something like this. But we still have this distinction between supply and quantity supplied to remember. All of the numbers taken together is supply. One of those numbers on this graph would be quantity supplied, right? So like right here, if you look at a price of $5, the quantity supplied would be maybe 50. Because at the price of $10, the quantity supplied is 100. If we lower the price from $10 to nothing, the quantity supplied would go from 100 down to nothing. Because the lower you make the price, the smaller the quantity supplied. Our table of numbers showed us that. But you don't say supply went from 100 to nothing. You say quantity supplied went from 100 to nothing. Because quantity supplied is the amount of good that sellers want to sell at a particular price. Like at the price of 0, how much do they want to sell? That's the quantity supplied. At $10, how much do they want to sell? The 100 that they want to sell is the quantity supplied. Supply is all those numbers taken together. It's the whole graph. So, does that make sense? Just make sure you get that straight, and it'll help you from getting confused, I think. That's the biggest confusion that people make, and if they make it, then they're going to end up with trouble in chapter 6, especially, when we start moving these things around, because it turns out in chapter 6 there are things that will change supply. There are things that will change demand. It's just in neither of the cases does price enter into changing demand or supply. You don't change the demand for a good by changing that good's price. You don't change the supply of a good by changing that good's price. So the quantity demanded will change if you change the price, but not demand, or not supply. If the quantity demanded, you put the buyers and sellers together, and the quantity demanded is equal to the quantity supplied. There we go. What do we call that? If the quantity demanded is equal to the quantity supplied, what do we call that? Now, in your answer, you can use one or more of the following words. Here they are. Demand, supply, quantity, price, supply, demanded, equilibrium, shortage, or surplus. You can use one of those words. You can do two of those words. You can use three of those words. I don't think under any circumstances would you need more than three of those words. All right, question number 2. Question 2. If the quantity supplied is less than the quantity demanded, so they're not equal, the quantity supplied is less than the quantity demanded, what would that be called? Same choices: demand, supply, quantity, price, supply, demanded, equilibrium, shortage, or surplus. But you can use, if you need to, more than one of those words. I'm not saying you do need to, but you can use one or two or three of those words. Question 3. If the quantity supplied is greater than the quantity demanded, what would that result be called? So if you figure out everything and, you put the buyers and sellers together, usually these are in the actual context that you're putting the buyers and sellers together and you're showing them all a price. And the buyers and sellers are figuring out, do they want to trade at that price and how much do they want to trade at that price? In this case, though, when they come together and they're looking at that price, the buyers say, you know what, at that price, we really, 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 really don't want to buy too much. But the sellers say, yeah, at that price, we really, really want to sell a lot. So what would that be called? And again, the choices are saying demand, supply, quantity, price, supply, demanded, equilibrium, shortage, or surplus. And put your answer down. It might mean more than one of those words. Now, the next question we have an actual table. Now, this table actually shows both demand and supply, right? It may not be obvious until I kind of show you or demonstrate to you that here we have all the prices in 50-cent increments between $5 and $9. All of the prices. So it is all the prices, right? When you talk about demand or supply, you say, oh, we want all the quantity demanded numbers and supply numbers at all the prices. Well, we got all the prices at least in 50-cent increments between 5 and 9. But you'll notice the first column of numbers there that are quantity numbers are just the demand. All of these are demand when you put them together with the price, because we have the individual quantity demanded numbers, and we're seeing how each of those fits with a price. So at a price of a particular price, in this case $5, quantity demand is 1,200. At $5.50, the quantity demand is 1,000, and so on, all the way down to when you have a price of $9, the quantity demanded would be 200. Those two columns of numbers then taken together would be demand. Right? These two columns together are demand because you got the prices and the quantity demanded numbers all together. This column shows for each of those prices what the quantity supplied is. So this number says, oh, at the price of $5, 500 is the quantity supplied. At a price of $9, 1125 is the quantity supplied. And all of these numbers of quantity supplied are tied to a price number, right? So we have here all of the quantity supplied numbers that go with all of the prices, at least between $5 and $9. And we're showing that. So this last column together with the price column, these two columns of numbers together are supply. So on the same table, we have demand and supply. When you put those buyers and sellers together like this, you can figure out something we call equilibrium. Based on this table, what is the quantity of good that is bought and sold in equilibrium? That's all I want for your answer to question number 4. Now, when it says bought and sold, let me explain that. All the time when someone buys something, somebody else has to sell that thing, right? I mean, so if you count up how many things got bought, it's always going to be the same as the number of things that got sold. Always. This is talking about what that would be in equilibrium, but anytime two people swap, even if it's not equilibrium, it turns out, the amount that's bought and sold, those two have to be the same number. Because if I'm buying something, someone else is selling it to me, you can't have a different number of bought things from sold things by definition. If someone bought that thing, someone else sold that thing, right? Now, the number that you might want to buy or sell, those might differ. But the number that actually get bought and sold, the number bought always has to be the same as the number sold. That always has to be the same. But we particularly want the equilibrium quantity in this case. For question number 5, based on that table, question number 5 saying, same table, what is the equilibrium price? What would be the price that would bring you to equilibrium? Now that price is going to be one of these prices here, right? One of these prices between $5 and $9. Okay, so we call this equilibrium. When the quantity demand equals quantity supplied, it's called equilibrium. And I don't want to put too fine a point on it, but I do want to say this. I feel the need to say this. The thing that makes it equilibrium, the word equal there, if you notice, is not the same, right? I mean, basically, this is equal with an I, and this is equal with an A. So that just, because of the language or something? Well, Equilibrium literally means something different from just being equal. As a matter of fact, equilibrium comes from Latin, and it means a balance of weights. And so the idea is that there's kind of a balance. And the idea, though, is there's push and pull by the buyers and sellers kind of against each other. And when that balance is reached, that they're each pulling, like if you think of like a tug of war, or they're pulling on the sides of a scale, but you can also think of it as a tug of war. When they're pulling exactly the same amount, well then, like the rope isn't going to move if it's tug of war, or if the size of the weight on both sides of that scale is exactly the same, well then there's not going to be any movement of the scale. That's the idea. The quantity supply is less than quantity demanded, so there you got the sellers don't want to sell very much compared to the buyers how much they want to buy. That's a shortage. Right? And then if the sellers have a lot to sell that the buyers don't want to buy, again, it's at that particular price. All of this is assuming, kind of behind the scenes, that you've shown the buyers and sellers a price. And at that particular price, in this case, the amount that the buyers want to buy is not enough to make up for, to equal the quantity that the sellers want to sell. So that would be a surplus. Kind of the handy thing about a surplus is at the end of the day, if there is a surplus, you can actually measure it, right? You just count up how much stuff the sellers take home with them that they didn't sell or that they leave on the shelves at the end of the day. A shortage is just as real. That is, there are people who were going to buy the good who can't get it at that price because the sellers basically ran out. We just have harder time if we were going to try and measure the size of the shortage. It probably would be in real life, in real situations, harder to measure. It's not that the idea is real, but it would be harder to measure how many people went away, empty-handed that would have bought it, right? Because probably if you're talking here, a very simple market would be like a swap meet or something like that. If you go to the swap meet and yeah, you went there and one of the little booths was closed because they ran out of stuff, we don't know how many people walked by that booth that would have bought something if they'd been open, right? But we just know, yeah, they were closed. They ran out of stuff before the end of the day. So the shortage is just as real. It's just harder to measure in most cases. There's only one place on this diagram, or this table, excuse me, where what the buyers want to do kind of matches up with what the sellers want to do, and that's at a price of $6, and it's with a quantity both that the buyers want to buy and a quantity the sellers want to sell of 800. So the answer to question number 4 was 800, and the price where it happens is at $6, and both of you got all that right. So you got that right. So it looks like 100% of you, if I may put it that way, got 10 points. Oh, good. It pays to show up, right? You got some extra points today. You might even get more extra points, but in order to do that, let me first ask, does anybody have any questions? Now, we're going to go over this table and talk about what happens if you're not at the equilibrium. Because obviously, there's a lot of places on this table which aren't equilibrium, right? So what happens there? We're going to kind of deal with that. But before we do that, would you please take out another card and put your name in the left corner. And in the right corner, put ECN 211 5C. C as in cat. Oh, sorry, 212. Oh, that's right. I forgot what time it was. 212. Yeah, for ECN 212. ECN 212, and this is 5C. That's what I'm trying to concentrate on. Now, give me your card when you're done with that. Oh no, you don't have any points here, right? So, you're going to either hate this or love this, or maybe not. I don't know. I think you are going to either hate this or love this. Because this is an oral exam. If I call on you and you do not want to answer, you may pass. However, if you pass enough, you won't get any points. So you might want to try and answer some of them, but they're not going to be that hard. I'll even show you how to start these. But the idea is we're going to talk about how you could interpret this table if, for example, on an exam, you were given this table and you were asked about various things, not just the equilibrium, but about the other parts of the table which are in equilibrium. So let me kind of demonstrate to you. By the way, we're doing this partly, we're doing the table because if memory serves me, your final exam, part 2, will have a table not exactly like this, but something like this, where you have to do what we're about to do, okay? So let me show you what I mean here. And so here's a little demonstration. So suppose we started out with this table, and I can even do this. Let me do this. There you go. Because we don't need the question part. Suppose we start out with this table, and the price was $9. All right, there's $9. If you notice, the quantity demanded does not equal the quantity supplied. Specifically, the quantity supplied at $9 price would be bigger than the quantity demanded. Now, hopefully you get the reason why that is. The price is higher than equilibrium. We already figured out the equilibrium price here is $6, right? So the price is higher than equilibrium, which means if the price is high, the sellers are thinking they can sell the good for a lot of money. So they make a lot of it, and they put it on the shelves or in their store, or they bring it to the marketplace if it's like a swap meet or a farmer's market or something like that. So they make a bunch of it, and they bring it to the market. But when the people who are buyers come by and look at it, it's not that they don't want any of it, but for $9, that's really expensive. They go, there's not many items that have a utility for us that's bigger than the $9 price. So I'll go back to what we were talking about before. So only 200 of the items would have been bought. Does that make sense? So how many would actually have been bought? The 200. It doesn't matter how many the sellers want to sell. How many actually got bought was the 200. Right? And how many got sold was the 200. How many the sellers were trying to sell was 1125. But how many they actually sold was 200. Does that all fit in? Make sense? Okay. So we have a surplus because the quantity supplied is bigger than the quantity demanded. And we can actually, since we have the numbers, we can actually figure out how big the surplus was. Right? Because what's the difference between how many they brought and how many they sold from the seller's perspective? They brought 1,125, but they only sold 200, so how many do they have left over? 925, right? Let's suppose now the price is $8.50 because the price has gone down from the $9. Do we have a shortage or a surplus? We still have a surplus, right? How big is the surplus? Well, that's the quantity supplied. But remember, they're bringing that much and then they're selling 300. So what's the difference between those two? That's how much you're going to have to take home with them. What's the difference between those two? 800, yeah. Is the price from there going to go up or go down? You got a surplus. Does the price tend to go down or go up? Going to go down. Now, don't get confused the fact that going down in the price means you're going up on the table, right? The lower prices are at the top of the table. But the price is going to go down. Let's suppose it goes down to, well, let's suppose it goes down to $5. I'll get there. Hold on. Let's suppose it goes down to $5. So now the price is $5. Is there a shortage or a surplus? There's now a shortage. How big is the shortage? 700. The difference between 1200 and 500, right? If you have a shortage, is the price going to tend to go up or go down? It's going to go up. Getting the hang of that? It's not that tough. Suppose it goes to, I hope it's not that tough. I say that, but maybe it is for you. Let's suppose the price goes to $7. Oh, that's up. That's up from 5, right? $7. If the price is $7, do we have a shortage or surplus? We got a surplus now. How big is the surplus? 350. Is the price going to go up or go down from there? Going to go down. Let's suppose it goes down to 550. Goes to 550. Is there a shortage or surplus there? There's now a shortage. The shortage, I'm going to tell you, because I want to move on to the next thing, is going to be 400, right? Does that make sense? Okay, so we'd expect from there the price would go up, and of course the next place for it to go up is probably there. It doesn't have to. It could overshoot to 650, but just to bring it into it, let's say it goes up to 60 equivalent. Once it's there, there's no shortage or surplus, right? The thing that makes the price change is somebody's going to try to deal with the shortage or surplus, and if there is none, then there's no reason for them to try and move the price. So that's why the equilibrium kind of is where you're going to be moving to if you're not already there. And once you're there, you stop there. You just stay there now. Like once we're there, we stay there. Okay, so even though it wasn't like it's not like something you were born to do or born knowing how to do. Do you get the hang of it now? You see how the prices, choices? Okay, so let's show another way of doing it. Now, this is similar to your study guide. I think I kind of promised you, more or less, that from my memory and the little research I was able to do about how I made up the final, just before I came to class, was that there is going to be a question, or maybe more than one, where you have to deal with a table like this and talk about the shortage and surplus and how big it is on the final, part 2. On your next exam, though, there's going to be something like this. And you go, well, that's completely different. And the answer is no, it's not completely different. Or my response would be, no, that's not completely different. It's pretty much the same idea. What do I mean by that? Well, because this one is just graphical instead of a table. But remember the whole idea of supply. The supply slopes up. It has up in its name. That's how you can tell which curve is which. Don't think about which one is like to the left or to the right or above or below the other one. The thing that makes them what they are is supply slopes up. It has up in its name. That's how every time you look at a curve and you see moving from left to right that is sloping up, it's supply. Demand slopes down because it begins and ends with a D for down. So as you're moving from left to right, the one that's going down is demand. The one that's going up is supply. The supply is telling you for every price, what is the quantity supplied that goes with that price? That's what it's telling you, right? So for example, at a price of $1, the supply curve is telling you the quantity supplied would be nothing. Because, the sellers don't want to sell you any if you're only paying them $1. Apparently, their costs are more than $1. They don't want to give you anything. If the price goes up to $2 is right here. Again, the price is, or just let me point out, the price is on the horizontal. The price is on the vertical axis, and here I'm kind of darkened the $5 and $10 increments there. So each of these squares represents $1. So right here is $2. The quantities are on the horizontal axis. And again, I've darkened the $5 or 5 unit increments. Here they're thousands, but so fives are darkened a little bit in terms of where the line is. So here we have $2. The quantity supplied would be 2 units. Do you see that? If the price went up to $3, quantity supplied would be 4. If the price was $4, quantity supplied, again, you take the price and it's kind of like the table. You take the price, you slide over to where the supply is, and it would tell you what the quantity supplied is. You may have to read it off the kind of bottom scale here. But at a price of $4, the quantity supplied will be 6. Okay? So you can do the same thing with demand. If the price was $1, the quantity demanded would be, gotta go way over here, would be 20. If the price was $2, quantity demanded would be way over here, 18. So again, you look at the demand curve to get the quantity demanded for that price. At a price of $3, you go over here, quantity demanded would be 16. At a price of $4, you go over here, slide over here, quantity demanded would be 14. Now, if I said, let's suppose that the price was $4. We already figured out at the price of $4, quantity supplied was 6. Also, quantity demanded is 14. So what would happen if we had a price of $4 is we would have since the quantity demanded is bigger than the quantity supplied, we have a shortage. Does that make sense? Because you're talking about, the way to tell that is, is the quantity supplied bigger or smaller than the quantity demanded? Well, quantity demanded is bigger than quantity supplied. So that means more people want this stuff than the sellers have to sell them. That's a shortage. We also know how big the shortage is, right? It's 14 minus 6, which is 8. The kind of fun thing about doing it on a graph, though, is you can actually count it if you want to. Because again, we're at a price of $4, right? Price of $4. How big is the shortage? It's 1, 2, 3, 4, 5, 6, 7, 8. It's 8 squares, so that's 8. You get the hang of it? So let's suppose that we start out, instead of at a price way down there, let's suppose we start at a price of $8, which is right there. $8. At a price of $8, here's the demand curve. Here's the supply curve. At a price of $8, do we have a shortage or a surplus? Okay, look, the quantity supplied. No, well, we're at $8. $8 is the price, right? Here's the quantity demanded. Here's the quantity supplied. Quantity supplied looks like how much? And how much is the quantity demanded? That's 6. So do we have a shortage or surplus if the quantity supplied is bigger than the quantity demanded? We have a surplus. Okay. I thought you said shortage. Okay, we have a surplus. How big is the surplus? It's 8, right? Because it's the difference between 14 and 6. If we have a surplus, is the price going to tend to go up or go down or stay the same from there? Price is going to go down. Let's suppose it goes down to $5, which is convenient because it's one of the dark lines, right? One of the thick lines. Price goes down to $5. Do we have a shortage or surplus? We have a shortage now. How big is the shortage? 4. What's going to tend to happen to the price then? Going to go up. Let's suppose it goes up to $7 right here. At a price of $7. Right, there you are. There's the supply, there's the demand at $7. I'll just put the marker there. At a price of $7, do we have a shortage or surplus? We have a surplus. How big is the surplus? So what? So the price would go down from there, right? What would be the equilibrium price? Just the equilibrium price? $6. What's the equilibrium quantity going to be? 10 is correct. Well, I hope that wasn't too hard. This is what you're going to have to do on your homework. Only the examples, the graph is different. It's on the one that's on page 43 of your study guide. I believe for the homework, there's not a different table. It's the same table. But for your exam, you might get, sorry, it's on the same graph. For your exam, you might get a graph that where basically the equilibrium is at a different place because the curves are moved around. So don't just memorize the answers from the table or from the what's that table? Sorry. Don't just memorize the answers from the graph in the study guide. That will help you for the homework, but for the exam, you might have to make sure you can do it with a different looking graph. Okay.